here is a fair die is used in the game. The probability of getting 6 different numbers on the die are shown with the probability distribution below. Basically means you have a 1 in 6 chance of getting a 1, a 1 in 6 chance of getting a 2, a 1 in 6 chance of getting any number on the dice. Okay? Find the expected value of the random variable where x is the number thrown. Basically what I want you to do is find the average. So if you were to let's say there's 2 ways of looking at it. Right? I'll show you the first way of looking at it is, you basically, to get the average, what you do is you multiply the score by the probability of getting that score and add them all together. So it's going to be 1 multiplied by a sixth is what? A sixth. What's 2 multiplied by a sixth? 2 sixths. 3 multiplied by a sixth? 3 sixths, then 4 sixths, 5 sixths, and 6 sixths. I add all these up together. I get 11, 15, 18. I'm going to get 21 over 6, which you're expecting to average a score of 3.5. Okay, that's expecting that they all turn up the same amount of times. Okay, so that's all you ever have to do. So just to say this again, you get whatever your score is, multiply it by its probability, do the same thing for every score and every probability in the table, add them all together, and it automatically gives you the average value. Okay, it's basically the average. Now, it costs €4 to play this game at a fun fair. The player rolls a die once and wins back the number of euros shown on the die. Using the results from 1, complete the following sentence. Okay. You average 3.5 as a score. So what does that mean for your average game? How much are you going to win? €3.50. Okay. How much does it cost to play a game? €4. Are you making a loss or a gain from each game you play?
Loss.
You're making a loss of 50 cents. So you're going to lose 50 cents a game. If you play the game 25 times, what happens then? 25 multiplied by 50 cents is going to cost you €12.50. You're going to lose €12.50 gambling on this particular game. Okay? If the expected value of the game is 0, then the game, we say, is fair. What should the cost be to roll the dice in order to make the game fair? The game fair means a game being fair means the amount you pay to play equals the average you're going to expect to win. So $3.50 is the answer. Okay? Now, it's really, these are handy enough, okay? We'll try another one. A charity got a license to run a raffle. There is one grand prize of €20,000, 20 additional prizes of €500. Tickets cost €10. When you read the small print, you discover that 10,000 tickets will be sold. Sheila bought 1 ticket and all the tickets were sold. Calculate the probability that she wins the grand prize. What's the odds on her winning the grand prize? 1 in 10,000. 1 ticket out of the 10,000 tickets will give you the grand prize. What is the probability of her winning a prize of 500? How many tickets will give you the €500 total? So it's going to be 20 out of 10,000, which is going to be is 1 out of 500, I think, or yeah, 1.
Where did you get 1 over 10,000 again?
It says 10,000 tickets are sold, and only 1 ticket will win you the grand total. So you have a 1 in 10,000 chance of winning that. What's the probability you win no prize? It's quite high, isn't it?
9,999.
9,900. Now you're nearly right. There's 21 tickets will get you a prize. There's 1 grand total prize. Take away 21. 79. So 9979 over 10,000. Okay. Now represent the situation with a probability distribution. So here's what they want us to do. Remember that table we had in the last one? So here's the. It's very similar to the dice table you seen a minute ago. So what we're going to do is this is your result, and this is the probability of that result happening. A result of you winning nothing. Winning 0 is likely to happen 9,979 times out of 10,000. Winning a prize of €500 is likely to happen how many times? 1 in 500. And then the probability of you winning the grand prize? 1 in 10,000. Now here's how you do this. What you do is, it says that's the probability distribution. Calculate the expected value. Can anybody remember how we calculated the expected value last time? It's a way of getting the average. How do we get the average though? You multiply them and then you add them together. So 0 times that number there, 0. 500 times 1 over 500 is 1. 20,000 times 1 over 10,000, 2. 20,000 multiplied by 1 over 10,000. Put in the calculator, you'll find out it's 2. So your average is meant to be 3. The average ticket will get you €3. Okay? Now every ticket won't get you €3. It's just that 21 tickets will get a very large amount of money, while the rest of us get nothing. Huh? No, it does it itself. It does it by multiplying the probability by the number. So you just multiply the score by the probability and it averages it for you. Okay? Is this how much are the tickets? Tickets cost €10. Is it a good bet?
No.
€10 with an average payout of 3 means you're minus €7 on average. Everybody on average loses €7 if everybody was to lose, so to speak. Okay? So it's not a good bet. You're losing €7 a turn. Okay? After this one, you'll know exactly what to do and we can let you guys try some of them. Okay, so it's a school fundraiser. It's spin the wheel. We're assuming that it's the proposal is to charge, it's €5 to play the game, and it has 6 equal sectors and they're equally likely to happen. So what does that mean if they're equally likely to happen? It's a fair, so it's a 1 in 6 chance. Is there 6 different parts? 1 in 6 chance, okay? Now, first of all, how many zeros are there? So, there is 3 zeros. 3 zeros constitutes what portion of the board? A half. The probability of getting a 0 is a half. Okay, probability of getting a 5? 1 in 6. Probability of getting a 10? And probability of getting a 15? I take it everybody's comfortable with making that out. X means your score, P of X means the probability of getting that score. Okay? Now, what I say, however, the school's maths teacher who loves statistics says that the game is fair and will win no money for the school. So, we're going to try and find the average value. If the average value is 5, what will happen? If the average person wins €5, what will happen? It'll break even, as in €5 to play, €5 you'll win on average. It's a fair game. You won't make any money from it. So if it's below €5, we'll make money. If it's above €5, we'll lose money. So let's find out. Anybody remember how to get the average, or expected value as it's called? Multiply, 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 and then you add them together. So the first one is going to be 0 times a half, 5 times a sixth, 5 sixths, 10 times 1 sixth, just do 10 over 6, and that's going to be a grand answer of 30 over 6. 30 over 6 is 5. It costs €5 to play the game, and on average we're going to win €5. So what does that mean about the game? The game is fair and hence won't make us any money. Therefore the maths teacher was correct. How would you redesign the wheel so that the school will make an expected €1 for each spin? We have to now redesign our wheel so that we get €1 instead of €1. So that the school would make an expected. We have to make sure that the average now turns out to be 6. How would you go about doing that? Suggest that we remove one of the zeros. Okay? We wanted our grand total here to be 36, yeah? If that was 36 over 6, that thing there would be €6, not €5. So I need a way of manipulating the odds. Okay? So instead of having 3 zeros, remember we had 3 and 6 of them were 0, yeah? So instead of having 3 and 6 of them being 0, I'm now going to have 2 and 6 of them being 0. This number is still 0. That's still 5, 6. That's still 10, 6. And that's still 15 over 6. But I need to add in a new score at the end. The score I'm going to add in is going to be... the score I'm going to add in has a 1 in 6 chance of happening. Would you agree with that? Has a 1 in 6 chance of happening. And it has to increase this to 36 over 6. So what are we at the moment? We're currently at 30, but we'd like to be at 36. So if I made this worth €6, so if I made this part worth €6, what would happen next is this. That would be 6 over 6. The grand total would now be 36 over 6. And our new average, our new expected... Oh. I'm trying to make it lower. Sorry, I went the wrong way. That's actually losing us €1 as opposed to making us €1. Okay, so what we're going to try is this. By increasing the amount I made us lose money, supposed to gain money. Okay, so what we'll do is this. We'll leave it the way it was. Zeros are half the board, yeah? What we had was, this totals 30 over 6, yeah? If that totaled 24 over 6, that'd be much better, wouldn't it? Because 24 over 6 would be an average value of €4 per game, which means that we're making €1 per game. So what I'm going to do is I'm going to lower one of the scores. It was the number 10, but instead of using 10, I'm going to use a number that's 6 below 10. 4. So if I make that €4 instead of €10, what will happen next is we'll now have a score of 24 over 6, which is €4. So all I had to do to redesign the board was to change the 10 into a 4, and that fixes it up. Okay. Okay, guys, that's us.